as a personality. But one of the things that comes across in the book and was very true in real life is he was exceptionally shy. Like he could sort of shine and really hit it at work when he needed to get things going, but he didn't want to be the center of attention as much as he wanted the things he did to have a legacy. And so, reporters would call him all through his life, and he was always very short with people on the phone because for him it wasn't about him. It was about the project. It was about the company. It was about something they all did, and he often downplayed his own role in it, even as I think you couldn't have done it without a guy like that, even if it hadn't have been him. And I don't think there's as many guys like that or women like that or people like that as people think. Everybody thinks they're that person, but I don't think that many people are.
Well, Jessamine, thank you for taking time to call us. It was great to reminiscing with you.
Yeah, thanks very much for talking to me.
You're welcome. Jocelyn, how much of what she was talking about fits into the engineers you know today?
Well, I think that engineers come in all shapes and sizes. I think actually maybe one of the things that's changed is, in the 80s, the engineers that we see in the book, they all kind of identify as outsiders. Computers are this brand new thing. It's this brand new field. And I would say even in the 90s when I went to college and majored in computer science, we felt like outsiders. We were the geeks. We were the nerds who, watched, who put Star Trek on the dorm television. And I think that the image of technology and computing has changed so much. When I look at the new college grads that Facebook is hiring today, I don't think they necessarily identify as outsiders the same way that we maybe did in the past.
I'm Ira Plater. This is Science Friday from PRI, Public Radio International. We're doing our book club, talking about The Soul of a New Machine with Annie Minoff, Jocelyn Goldfein, and Stephen Levy. Steve, I remember reading your book, the Insanely Great, about the life and times of the Macintosh, another machine, a machine that really did change the way, not like this machine did. What was the difference between Steve Jobs and how you saw what was going on in the Soul book?
Well, I guess the difference, as I mentioned before, he really motivated his team, saying, we're going to make a dent in the universe there. They weren't just taking on IBM, that was like a big part of it, but they were saying, well, if we don't take over IBM, it's going to be 1984, in the Orwellian sense, as opposed to the Steve Jobs sense. And he convinced his team that they were building something that was totally different. And to be honest, it really was. I read this now thinking, of what Larry Page, the head of Google, said. He said, really, it's not worth taking on a project to be 10% better than your competitor. You really have to take on something that's like much, much better, 100 times, because Moore's law makes it possible to do something like that. And in retrospect now, I think, I'm again, this is my previous readings, that Data General was totally, ignorant of that equation there. They shouldn't have been building the next mini computer. They should have been building the next microcomputer or the Macintosh.
Let me get to the phones now. I asked for the engineers to call in, and they are calling in. We go to Ned in Portland. Hi, Ned. We have a couple of minutes before the break. Welcome to Science Friday.
Hi, thanks for having me on. Long-time listener, first-time caller.
Thanks. Go ahead.
Yeah, I was an engineering manager at Tektronix, which is one of the computer measurement companies that would produce oscilloscopes, and they had a division that made workstations, and we used some computers hardware from the Route 128 from a company called Prime Computer, which was a competitor with Data General at the time. And I remember this book, I still have it coming out, The Soul of a New Machine, and it influenced me to leave Tektronix in 1982 and join Intel Corporation, because Intel's coming out with a 32-bit machine versus the 16-bit machines that were referenced that Data General was trying to move away from. And I ended up at Tektronix selling as a factory sales representative to both Data General and Digital Equipment and Prime Computer to sell them on Intel architecture, and that microprocessors were the way forward. And unfortunately, they were stuck in their own engineering mire and could not actually make that leap from the mini computer to the microcomputer. But the book by Tracy Kidder, Soul of the New Machine, was definitely an influence for me to change my career, which was a great career for me.
Do you think other engineers did that too? Change their careers?
Yes, there were people at Tektronix I know, because we would talk about this book, The Soul of the New Machine, and we talked about the mode bit, for those that have read the book, about having a mode for 16 or 32 bits, and the Tracy basically said, no, you can't do that. They wanted a more, rather than having a 32 or 64-bit mode, or 16 or 32, wanted to have more of a seamless architecture. And we had all those discussions, and people were disillusioned where Tektronix was going to go. They were kind of in the same boat as Data General and Digital, trying to stick to the knitting that they knew and not embrace the microprocessor, which, as we know today, is how the industry has really shifted.
Well, thank you for calling. It's a great little reminiscence about the old days in the 128. We're going to take a break. When we come back, we're going to talk more about the Soul of a New Machine. Stay with us. Our number, if you want to comment, 844-724-8255. You can also tweet us at SciFri if you've read the book, or you can relate to it as someone who was around at that time working in the industry. We'll talk about it when we get back. Don't go away. I'm Ira Plato. This is Science Friday from PRI.
Support for Science Friday comes from Cancer Treatment Centers of America, offering genomic testing through its new Centers for Advanced Individual Medicine that may reveal additional treatment options for individual cancer patients. Learn more at cancercenter.com. And by Lumosity.com, brain training designed by neuroscientists that has been used by 60 million people worldwide, with personalized training programs to challenge memory, attention, and problem solving. Learn more at Lumosity.com. Also from O'Reilly Media, with Learning Paths video training, a direct route to learning a new skill or technology, from big data to programming languages to UX design. Learn more at O'Reilly.com/go/sci-fi.
It's back to school time, but for some kids, mom and dad are the teachers.
We are merely trying to protect those children who may be vulnerable and at risk of serious harm.
The lawmakers trying to regulate homeschooling, the lobby that's trying to stop them, and the kids in the middle. That's next time on The Takeaway, weekday afternoons at 3 on 93.9 FM.
WNYC receives support from City National Bank Wealth Management, providing investment management, trust, and financial planning services to clients throughout New York. More information at cnb.com/wealth.
Listening to Science Friday. Coming up at 3, John Hockenberry and The Takeaway on 93.9 FM. And on AM 820, It's the World.
This is Science Friday. I'm Ira Flato. If you're just joining us, we're talking about The Soul of a New Machine, Tracy Kidder's classic book. It's our Sci-Fi Book Club selection. We're wrapping it up. With me is Stephen Levy, Jocelyn Goldfein, and Annie Minoff, our regular Sci-Fi Sci-Arts producer. Annie?
We were talking earlier about how well this book might reflect engineers today. And I don't know if this struck you, but to me, the big revelation of this book was what aesthetes these engineers were, that they were really concerned about imposing some sense of beauty or, on these machines. And Jocelyn, I wondered if you connected with that at all.
Oh, yeah, absolutely. I mean, my career's in software more than hardware, but we take incredible pains to write beautiful code, and there's different sort of standards of beauty. There's sort of how readable is your prose, but also, I mean, if you think, I would compare it to writing a novel. There's sort of the prose itself, but there's also sort of plot lines and character development and sort of climax and anticlimax. And you have analogies for all those things in the way you structure your code, in the way different pieces interact and what it's ugly to have side effects. And so absolutely, I think of software engineers as really as craftsmen. You know, the basement in Tom West's workshop, you know, that resonates with me. We're particular.
Yeah, that workshop scene is amazing. So Tracy Kidder actually brings us into the home of this engineer, Tom West, and he describes in great detail this guy's basement workshop. And, you know, he's got all of his screws and his nuts and bolts in the right containers. And you just get a sense of, you know, this is the place where he can really unleash that artistic side and, you know, create the perfect thing. Because, of course, at work, you have to make compromises, right? You have to ship the machine.
Yeah.
But in the workshop, you don't have to do that.
Tracy Kidder, when we talked to him earlier in the week at the Google Hangout, he was made sure that we understood that it was the beauty, that they were really concerned with the quality and the beauty of the product that they were putting out. Let me go to the phones because I have, let's go to Steve in Oakland, California. Hi, Steve.
Hi, I'd like to talk about how this striving for elegance and beauty was so influential on me when I first read this book when I was 12 years old in 1982.
Wow.
This book was given away at a university bookstore. It's actually a bookstore where I taught myself to program before I owned a computer of my own. But reading these personal accounts of not just the engineers, but their youth, what they'd done, the phones they had messed around with, the ideas of finding beauty in math that they found, it was incredibly influential on my life. And I'd love to see more stories like this, sharing a greater diversity of all types of people in creative endeavors, because it makes a big difference when people see themselves in these sort of lights.
You know, we hear artists talking about the beauty of what they're doing, but you don't always hear that engineers consider more or less what they're doing an art form themselves in the details that they're putting in it. Would you agree, Steve?
Oh, absolutely. I mean, when you find elegance in a simple solution, at times, you know, the beautiful code was necessitated by the technical limitations of the computer. You had to write very compact, very efficient code because things were expensive, memory was expensive. But this sort of knowing when you've hit across an elegant design, it's the same sort of feeling an artist gets when they know that it's time for them to abandon their art rather than continue to crank away at it. They see a point where it's finished, it's elegant, it's done, it's beautiful.
All right, thanks for your call. Interesting phone call. Steve Levy?
Yeah, right about the time this book came out was when I was just starting to write about computers, and I was focusing on computer hackers. And this was one of the very few things written about programmers which broke out of that mold of these loners in basements who couldn't talk to other people there. And I just treasure those few pages that really dug into the micro kids here. I remember reading it back there, and it was a good pointer for me as I embarked on my journey to figure out what hackers are all about.
You know, when we talked to Tracy Kidder earlier, we asked him about whether anybody in the book, or people he was, Tom or anybody, could envision the internet, and they didn't. You know, very few people were able to envision the internet.
Right. Well, I think that is very true. But the tragedy of the mini computer industry was they couldn't even envision the personal computer while people were buying personal computers. Their big competitor, DEC, very famously, their CEO Ken Olsen very famously said there's really no reason for a person to have a computer on his or her desk. And I think the ultimate statement is that the internet domain for Data General, DG, eventually got bought by Dollar General.
There's something that the caller actually brought up, Steve brought up, that I wanted to follow up on, because he said it was great to see a portrayal of engineers as kind of creative people, and that it's great to have those stories out there that show, just the diversity within engineering. And of course, one of the ways in which this book was not diverse is there are very, very few women engineers in it. And so I wanted to ask Jocelyn, just, on the basis kind of the numbers game, we have, I mentioned this team of 30 computer engineers. We have one female engineer on that team. And how much has that changed just on the basis of that kind of alarming ratio in tech today?
Oh, it would be wildly different today. It would probably be 2.
Double the number. Right.
Oh, yeah.
Maybe 3.
Well, why is that? Do you have your own theory about why that is?
I think that it's actually funny that Stephen brought up, actually, I think one of the crucial points of it, which is we imagine computer engineering to be this lonely, dry, mathematical, you're sitting in a basement, you're on your own. And what's great about this book is that, it shows that for the lie that it is. It's actually this incredible, collaborative, team-based effort. and the ways that you interact with each other are as or more important as the ways you interact with the technology. But I think that's not how we understand it in society, and so that gives rise to, I think, making women and girls, really girls, see it as, you know, not accessible to them, or something they're not going to be good at, or something they wouldn't like to do, or that would make them unpopular. And so I think we see this waning of interest in girls from very young ages, you know, to we reach college, and if you look at the computer science major today, it's actually less gender diverse. In the mid 80s, 86, CS was probably more than a third female. And today it's about 18%. We're going the wrong direction.
So do we need to make it look more, to show the beauty of what computer engineers really see in it?
Yeah, I absolutely think that if we understood programming and designing of hardware to be the creative and collaborative act that it is, you know, it would be infinitely more widely appealing. You know, another kind of diversity, it's not mentioned in the book, but we can probably assume that all 30 of those engineers were white. And I think that, you know, the more we kind of bust open these stereotypes about what the work is like, the more people of all walks of life, I think, will come to discover how fulfilling it is to do this kind of work.
Well, I can't find a better way to wrap it up than with that statement. Thank you, Jocelyn. I want to thank all of you. Jocelyn Goldfein, an angel investor, former engineering executive at the Facebook and VMware. She was joining us from Palo Alto. Steve Levy, editor-in-chief of the online tech publication Back Channel, author of Hackers, Heroes of the Computer Revolution. Good to see you again, Steve. And Annie Minoff, Science Friday's SciArts producer. Thank you, Annie, for putting this all together for us. And if you missed our book club meeting, as I say, we were meeting at Google here in New York City earlier in the week. Never fear, you can listen to a podcast of our conversation with our author Tracy Kidder at our website. That's at sciencefriday.com/soul. The UN has declared 2015 the International Year of Light. We've been celebrating throughout the year by exploring the captivating characteristics of light. And today we're going to talk about little devices that put out light, LEDs. Lighting has come a long way since Tom Edison lit up his first incandescent bulb in the 1880s. LED bulbs, they're popping up everywhere, on planes, car headlights, in your phone. When you buy a new light bulb now, chances are it's going to be an LED one. And at the heart of every LED is not a little wire. If you open up an LED, there's a semiconductor in there. And where you find a semiconductor, you can be sure you're going to find an engineer trying to tinker with it. And my next guest is researching how to wirelessly stream data through everyday LED bulbs. Can your lamp become your Wi-Fi station? He's here to tell us the state of Li-Fi. That's a term that he coined. In the future, we'll be logging on to networks. Could that be as simple as flipping a switch on your light bulb? Harold Koss is a professor of engineering at University of Edinburgh in the UK. He's also co-founder and chief scientific officer at Pure Li-Fi. Welcome to Science Friday.
Hello. Good afternoon.
This is an old idea, going back, way back to Alexander Graham Bell communicating with visible light, right?
That's correct. Alexander Graham Bell was the one who invented the photophone, and in fact, he thought this is his biggest invention, even bigger than the telephone.
Now, you've been working on a system called Li-Fi. There are LEDs and remote controls. Tell us how a Li-Fi system works and how different it is from what we have now.
Right. So you basically said it in your introduction. LEDs are semiconductor devices, a little bit like transistors, and they have the property that we can change the light that comes out of an LED very, very quickly. So that changes in the brightness is what we exploit in order to encode data extremely fast. So that the receiver will be a decoder, a photodetector, which will then see these changes in the light intensity in a way a human eye would not be able to detect. For a human eye, it would be simply constant light. But for a photodetector, it is a change in the intensity, and then we have algorithms that recover these changes in intensity and get back the data stream. And we've shown with LEDs that we can, in the lab, we have shown data rates of up to 15 gigabit per second, and that is at the moment more than twice as fast as the fastest Wi-Fi.
Well, so besides just the speed, what advantage does an LED flashing up and down like that and sending up zeros and ones have over a Wi-Fi or even over a laser light?
Right. There are numerous advantages. One of the biggest advantages is that we use spectrum. We use the visible light spectrum, which is by nature about 10,000 times larger than the radio spectrum we use currently in our cellular communication systems. So we can use a vast amount of free spectrum, which is unlicensed and basically installed everywhere. You mentioned it in cars, in our LED lights at home, in street lights, and so on. So it's ubiquitous, it's already there. We can use existing infrastructure in creating a very efficient sort of cellular communications. That's one advantage. The other advantage is that we have this capacity, this additional capacity, these additional SAT data pipes that essentially come for free, and that alleviates what we call the radio frequency spectrum crunch. If you go to an airport into crowded areas and try to log into the Wi-Fi, you probably will find out that data rates are terribly slow, and that's because of the limited availability of radio spectrum. So it is providing higher capacity. We use existing infrastructure and therefore don't have to have these large infrastructure investments, and also it is more secure. If you go out and try to sort of log into Wi-Fi networks, probably you will see 20 to 30 Wi-Fi networks, and that basically would mean you could break into them, so eavesdrop into ongoing communications. It's a standard problem at the moment. So, but light wouldn't go through walls, and therefore it would be more secure than Wi-Fi. And the fourth big advantage is that we can use Li-Fi in areas where we traditionally can't use radio, such as underwater or in intrinsically safe environments like petrochemical plants or oil rigs everywhere where an antenna could spark an explosion.
Interesting. We're talking about the new world of Li-Fi with Harold Haas on Science Friday from PRI, Public Radio International. Now, could you, we're talking about a lot of times about the cars and self-driving cars and the need for cars to communicate with each other if they're going to be, being safer. Could your headlight flash an LED at the other car, and so they sort of talk to each other as they're approaching and know where they are and exchange communication?
Yes, this is indeed one of the further applications that the car headlights. If you go to a BMW, for example, they use headlights where the white light beam is generated out of three LEDs, a red, a green, and a blue LED, and these are laser LEDs and cover up to 600 meters. And we can use these LEDs to transmit sort of data from car to car and use the backlight to relay back the information. And this is a way we can enhance safety on our roads and even extend the vision. Sort of normally you see the car in front of you, but if you were able to relay high-definition video from, say, 3 cars in front of you, you could see earlier what's happening on the street,